Hello, and welcome to today's lesson on the metric system and unit conversions. So to start with, measurements in science and in the world in general. In science, we use what's called the Standard International or SI system of units. This is a system that has been agreed upon among scientists around the world so that everyone who's performing experiments and taking calculations, taking measurements, use the same system, so we don't have pounds used in one experiment and kilograms used in another and ounces used in a third. It's all the same setup with the same units being used. And that's the consistency part we're looking for. Down below in this table, you see some base units for the SI system. So you'll notice length, your system uses, for length we use meters. For mass, instead of grams, we use kilograms. The rest of them are all congruent or similar, or the same as your metric system base units. Kilogram is the one difference here that we use. So mass uses kilograms instead of just grams. You see that here, abbreviated kg. Everything else has just a singular unit. Meters is m, seconds is s, Kelvin is k, so on and so forth. You will notice on that list of units that we don't have things like area, volume, weight, force, or speed. These are all what we call derived units. Derived meaning they come from multiple base units mathematically being put together. And so for example, area is calculated taking the length of an object times the width of that object. Let me change my color quick. And so if we take length times width, we're taking meters times meters and getting meters squared. For speed, the equation for speed is distance divided by time. Distance, we've talked, is measured in meters. So speed is the same as saying meters and dividing it by time, which is measured in seconds. So your units for speed are meters per second. But that's an example of a derived unit. It's something we would derive in class or in science. The reason we use the metric system, one of the benefits and advantages to the metric or to the SI system, is that we have prefixes that denote large and small numbers. So instead of using a whole bunch of zeros and having a very long and drawn out number, we can put a prefix there instead. So for example, the prefix kilo, a lot of us have heard of kilograms or kilometers. Kilo or kilo represents the unit or means 1,000. So a kilometer is the same as saying 1,000 meters. Some other prefixes, things like mega. So a megabyte is the same as a million bytes. A byte is the base unit of information. And so a megabyte is a million of those little information bits. Giga is another common one, especially with technology, computers, video games. A gigabyte is a billion little bytes worth of information. If you start talking bigger and bigger with technology-wise, you get into video games and you have terabytes. Tera is 10 to the 12th, or a trillion. And so we'll talk a little bit about that here. But these are some common ones. So metric, or for kilo down at the bottom, you see kilo is the same as 1,000 meters. So 1 kilometer is the same as 1,000 meters. A megameter is a million meters, and a gigameter is a billion meters right there. On the flip side, if you would reverse that, so kilo means 1,000, so 1 meter is the same as 1/1000th of a meter. It's the same as 1/1,000,000th of a megameter, and 1 meter is the same as 1/1,000,000,000th of a gigameter. But that is your simple conversions there. So it goes the same big and small. So those are all getting bigger. Getting smaller, we're talking decimeters or deci, the prefix centi. A lot of us have heard of centimeters or centigrams or milligrams. So deci means tenth, centi means hundredth, milli means thousandth. A micrometer, micro means millionth. So 1 micrometer is 1/1,000,000th of a meter, or a million micrometers equal 1 meter. Nano is another one. We talk about nanometers, we talk about nanobytes, nanograms. All of those are using the prefix nano, which means billion. So again, 1 decimeter is the same as a tenth of a meter, or 0.1 meters. Centi is 0.01. Milli is 0.001 or 1 millionth, and micro is or 1,000th, sorry, on milli, and micro is 5 zeros and a 1 after the decimal, which means 1 millionth. But those are all examples there. For this class, you will be responsible for knowing values from 10 to the 12th to 10 to the minus 12th. So up on the top side, 10 to the 12th is tera, so that's that terabyte. That's a trillion. Giga means billion. Mega is million, so that one's not terrible. So the mega millions is a lottery that's done. So that one you can kind of remember there. Kilo means 1,000. Hecto and deca we don't use very often, but hecto means 100, deca means 10, or a power of 10 to the first, 100 is 10 to the second. Using scientific notation makes these not so terrible when you get those really big numbers. So instead of trillion, you can write, instead of writing 1 and a bunch of zeros to get trillion, you can write 10 to the 12th to be the same number. Billion is 10 to the 9th, million is 10 to the 6th, kilo is 3rd, hecto is 2nd, deca is 1st. 10 to the 0, this is our base unit. And that just means 10 to the 0 power, which means 1. So we don't have to move the decimal at all, it's there. So for example, you would have your meters, your liters. So for your base units, you'll have things like meters, liters, grams, seconds, Kelvin are all your base units, all base units that we use in this class specifically. Then you have deci, centi, milli, micro, nano, and pico. I'm going to give you a different way to kind of look at those and remember those, hopefully. That might be a little bit easier than just looking at this chart and saying, oh my goodness. But this, going out past that spot that I expect you to know, and that you'll need to know, we have bigger numbers. So we can go clear out to 10 to the 24th with this chart. So we have iota, zeta, exa, and peta, or peta. I'm not sure which one it is. And down at the bottom is femto, alto, zepto, and yocto. So those are all prefixes that we can use as we get really big and or really small. So this is the mnemonic that I give kids, I give students, I give you guys to help you remember the prefixes. And so it's hard to read and I apologize, but it starts with the great mighty King Henry died by drinking chocolate milk under Nebraska's prairie. So if you look at this, the starts with T, G is great, my starts with M, this is mighty, I couldn't write the whole word mighty so I put mighty. King starts with a K, H starts with an H, or Henry starts with an H, died starts with a D, buy is a B, drinking is a D, chocolate is a C, milk is an M, under starts with a U. This is the one that doesn't fit perfect. And the last word is prairie. It's hard to read. I apologize. Starts with a P. You will notice, for example, prairie starts with P. Pico is the prefix that prairie represents. Pico is 10 to the minus 12th, so prairie and pico both start with a P. Nebraska, it starts with an N, so does nano, which starts with an N. Under and micro are the ones, this is the one that doesn't match perfect. Because we have milli and we have micro, milli got the M, micro gets a Greek letter mu, which looks like almost a backwards U. It's kind of a U with a tail on the other side, is how micro works. But it looks like a U, so we give it, if I use under on the words, it kind of lines up, kind of makes sense over there. And then as you go back, you get milk and M, chocolate and C for centi, drinking in deci. Deci and deca are the two that are kind of difficult because they both start with D. Deca has DA. So there's two letters here. So if you get a decagram, it's going to be written as DAG, is decagram. So it's not just two letters, it's three on that one. The rest of them, hecto is H, kilo is K, mega is M, giga is G, and tera is T. Mega, so the difference between mega and milli is mega is capitalized. So if there's a capital letter, if there's two of the same on the really big side and the really small side, the one that's on the big side is going to get a capital letter. So for example, mega gets a capital M. As you go out farther, if you go really big, really small, yada is 10 to the 24th is a capital Y. Yocto is 10 to the minus 24 is a little y, as a lowercase y. So that's the capital versus lowercase there. We can use these to convert. So for example, if I wanted to convert let's go 1.25 kilometers into meters. We know that, and I use the factor label train track method, so I have 1.25 kilometers, and I'm going to put a big long track underneath it and separate with a vertical line. So everything separated by a vertical line is multiplied, so put a little multiplication sign up here. And then this big long one underneath, it represents the division bar. So 1.25 kilometers, remember I have to cancel out units. So in this case I have kilometers on bottom, and kilo means 1,000. So 1 kilometer is the same as, 1,000 meters. So I can put 1,000 meters, or I can use 10 to the third. I'm going to use scientific notation, maybe. I get my pen to work. Apparently I'm just going to hit buttons today. 10 to the third meters. And because I have kilometers on top and kilometers on bottom, I can cancel those off, so I'm left with just meters as my unit. And so then what's going to happen is I'm going to take 1.25 here times 10 to the third, which is the same as saying times 1,000, and I'm going to get 1,250 meters. That's going from a big unit to a small unit. On the flip side, if we would take and we would go from 1.25 meters we would go to kilometers. So I'm going to put 1.25 meters down here. Draw my division bar, separate by a vertical line. I'm going 2 kilometers, so I need to put kilometers on top. 1 is always going to go with your prefix, and then your power of 10 is going to go with your base unit. So in this case, I have 1 kilometer. And I know that 1 kilometer is the same as 10 to the third, or 1,000 meters. So I'm going to put 10 to the third meters on bottom. And so I have meters on top and meters on bottom, and they're going to cancel. I'm going to use 2 lines to show it's an equal sign there. And that's going to be 1.25 divided by 10 to the third, which is, because it's just a power of 10, we can move the decimal place. So I'm going to have 0.3 places to the left is going to be 0, 0, 1, 2, 5 kilometers. And so there's your conversion from meters to kilometers going that way. If you are going from a big unit, such as kilometers, to a smaller unit, such as meters, you are going to multiply by your total number. If you are going from a small unit to a big unit, you are going to divide by that same number. Okay, so that is going to be your math skills there, is multiplying and dividing by those numbers. Oops, skip the page. So here's another example. We want to go from 1.85 meters into centimeters. 1.85 centi is 10 to the minus 2. And so because that would be on bottom, we flip it and put it on top. You get, which is 10 to the second is 100. So you get 185 centimeters. And likewise, if you're here, you're going from a smaller to a bigger. So you're going to divide. So 185 divided by that 100 gives you 1.85 meters. And I'll give you a chance to practice this here in a second. That's an exit ticket. We'll skip that for now. But we can talk about base units and derived units and things of that nature. This is where I'm going to leave you. So here's some practice questions. If you would like, I can get you the answers. Just shoot me a message and I can tell you if you did it correct or not. But this is where I'm going to leave off. So on the first one, DM, I'll do the first one with you. We're going from decimeters. So D, single D is deci. So I have 55 decimeters. And I am going to meters. So because I'm going to meters, I need to put 1 meter on top. Ooh. Put 1 meter on top here. and whoops, I apologize, not 1 meter on top. Because decimeters are on top, I need to put 1 with my prefix. So 1 decimeter, and then deci has a value of 10 to the minus 1. So that goes with my base unit of meters. So 1 decimeter is the same as 10 to the minus 1 meters. And so 55 times 10 to the minus first is going to move that decimal over 1 spot. So you're going to get 5.5 meters out of that. So that's going to be your first answer. It's 5.5 meters. I'll let you try the rest. So 1.6 kilograms to grams, 2,800 milliliters into liters, 6.1 meters into millimeters, 50 kilograms to grams, 4,630 microliters into liters, and 0.42 kilometers into meters. I wish you the best of luck, and I will see you next time.